I will present a number of projects, not all of the projects we are working on. Probably you, the people who work with us, maybe they miss some project, but I collect a number of projects with different types, working with companies or more basic research projects. So I will start with this short introduction. Yes, Tecnalia is the largest research center, private research center in Spain. About 1,500 people working from different countries, mainly from Spain, but we have experts from different countries. We have a very business orientation. So our objective is to transform technology into GDP, into value. And we are also very active in European projects. Maybe some of you have been working with us in European projects. We have several scopes of action: advanced manufacturing, sustainable mobility, urban ecosystem, health, and where I work is the energy transition. And all of them connected with a new trend, also the digital transformation. We have three main types of activities. Laboratory services is closer to the companies, is more certification and this type of things. We have the largest activities R&D and innovation projects, and we have also development of investment opportunities, and I will mention a couple of them during my presentation. We work with mainly small and medium enterprise companies, but also with large companies. So talking about offshore renewable energy, we mainly work on offshore wind projects, fixed, what we can say more traditional offshore wind farms. But our main activity in offshore wind is for floating solutions. We have a long-term record working on wave energy, also a bit on tidal, and we are also now exploring offshore solar. We have been working in renewable energy for more than 15 years. Actually, we started in 2004. We have produced a lot of some patents. We have contributed to international committees, organizing events. And what I mentioned before about creating new business opportunities, we launched or created two technology-based companies. One was Oceantech, and I say was because now this technology has been acquired by an industrial company, a Basque known company, IDOM, that they are 100% owner of this wave energy converter. And we in offshore wind, floating offshore wind, we created the company Nautilus Floating Solutions together with 4 industrial companies. And we are now in the process of setting up a demonstration project for this technology. As I said, we are very active in European projects. We have participated in around 20 projects, leading 5 of them. And our success rate is usually higher than the average in Horizon Europe project or in the previous framework program. We hope to have a similar or even better in the new Horizon Europe. So I mentioned at the beginning that I would like to put my presentation in the context, and it's quite recent. This is a communication from the European Commission was made public last week. So it's very, very recent. It's a new offshore renewable energy strategy. You can see some estimation of the growth of these technologies, mainly offshore wind, that could achieve 60 gigawatts by 2030 and more than 300 or about 300 gigawatts by 2050. All the renewable energy in the marine environment, wave and tidal mainly, the estimation is around or a bit bigger than 1 gigawatt by 2030 and 40 gigawatt by 2050. As you can see in the graph on bottom right, that this strategy is not only talking about floating. They distinguish this technology: floating wind, offshore wind. It means fixed offshore wind, tidal energy, wave energy, and floating photovoltaics. It's something that is quite new. Photovoltaics is we are working with our colleagues from the solar department. We have at Tecnalia another department for solar, and we are working together now, exploring the option for floating PV, mainly first in reservoir, let's say fresh water, not in offshore, but maybe in the future, offshore PV could be another new renewable technology. Okay, but our industrial associations, let's say Wind Europe and Oceanate Europe, are even more ambitious. I have to say that in the previous strategy, I think, and in this context, I think it's important, I think it's for the EU27. So in principle, UK is not included. And in this estimations, is for the whole, including for the whole Europe, including UK. So Wind Europe has a vision of 450 gigawatt by 2050. So very, very interesting figure with a lot of, that means a lot of market, and with a estimation of a floating wind mainly in the South Europe, that could be a new big business. On the other hand, Oceanate Europe has also a more ambitious plan for 2050, around 100 gigawatts. That could mean around 10% of the European electricity consumption by this year, and creating a lot of jobs. And I hope Henry can give more information about the benefits from developing this type of technologies in Europe. So in this context, there will be several challenges. Probably the most important one, or the companies are analyzing, is the financial challenges. There will be also environmental and permitting challenges, mainly more concerning public administration, but also companies. And my presentation as a research center is more focused on, or try to give examples of R&D projects to overcome R&D challenges. There are plenty of them, you can imagine, and I will explain some projects that we have been working. Some of them are ongoing, some of them have already finished, and I hope you can learn a bit about these projects. Because of the time, I will give some general messages from this project. The first one I want to mention is about floating wind. It's a European project, already finished, and was how to develop a floating structure for 10 megawatts or even higher wind turbines, and in deep waters. So in this project, we worked 4 different concepts, and 2 of them went to a more detailed study, including tank testing, and one of them was the Nautilus solution, that is a semi-submerged platform. And the idea here was to analyze how or to reduce the cost, or how to reduce cost for these big turbines that now, when the project started, 10 megawatts seems very high, and now let's say it's the average for floating wind, and there are some companies even talking about higher. That's why we are continuing working on this, but in this case only with local companies. This is a project funded by the Basque government, and is again to overcome some technology challenges for big offshore wind turbines, including coatings, tower design optimization, connection systems. So different aspects. Each company is interested in one specific aspect, and we are working with all of them to overcome these challenges using new technologies or doing research. This is another project funded with by the Basque government. It's also about floating wind, but in this case, not focusing on the wind turbines, but on the substations. And here, the concept is to develop floating substations. If we go deeper offshore, of course, the turbine will be, we will need floating turbines, but also floating substation. And here's a new challenges, new problems, and we are also working with a number of Basque companies to analyze and give a solution to these problems. I'm moved now to wave energy. This is already a finished project led by Tecnalia. it consists of testing a prototype of a wave energy device. Is the company I mentioned at the beginning that started from a spin-off from Tecnalia, and during the project, the technology was acquired by the industrial company IDOM, and this device was connected in BMEP for 3 consecutive winters with some changes in the configuration, for changes, for example, the turbine. Has produced a lot of information about testing and analyzing how a wave energy device, this is not a full-scale device, let's say it's a partial scale device, but with a lot of hours of knowledge of real operation at sea. This device was tested at the BMEP test facility in the Basque Country. This is another European project. Now we are talking about Tidal. It's another project led by Tecnalia, more focused on optimizing the blades and materials for Tidal device. Try to reach over 2 megawatt Tidal turbines, addressing mainly the blades. Okay, I mentioned before that we are exploring together with our colleagues of the solar department the floating solar, and we are collaborating with them, mainly giving a solution for mooring system connection, also electrical connection, but mainly around mooring system, taking our experience for designing the device or the wave energy devices, trying to transform this knowledge to the mooring of solar installations offshore. As I said, we are starting analyzing the potential of let's say inland or reservoir or other lakes installation that the environment is not so harsh, and but we are also analyzing the possibility of moving solar photovoltaic installation offshore. That this is you can understand is a big challenge. And also we are analyzing, this is a European project. We are here giving more support on electrical parts and electrical connections, but it's a multi-functional platform, including mainly offshore wind and aquaculture. So this is led by an Italian institution, RINA, and we want to test, this is what we call an innovation action, so it's a demonstration project to test a multifunctional platform combining renewable energy and fish production, so aquaculture.
1 minute left.
Yeah, sir. And just to finalize, this is a project, it's an in-house investment to develop a laboratory for real experimental sea. This is connected, installed already more than 2 years in operation. Is we call HARS Lab. It's a real offshore laboratory to test materials and components in real offshore conditions. And this is another project that is for an SME. It's a patent promoted or created by Tecnalia that was transferred to an SME to facilitate the electrical connection of floating structure, could be offshore wind, wave, or other type of structure. And this is this company is trying to commercialize now this solution based on a patent from Tecnalia. And this we have also more pure research in collaboration with the University of the Basque Country and the Past Center for Applied Mathematics. It's a kind of a joint research laboratory in which we have more let's say the academic research. And finally, just to mention that we have participated in several organizations in Spain, in Europe, worldwide. And also I would like to mention that we have collaboration agreement with the Offshore Renewable Energy Catapult and also with the University of Edinburgh. And I'm very happy to work in this case very closely with Riefi, our next speaker. Thank you very much, and I hope you enjoyed the presentation.